Imagine standing beneath a perfectly clear night sky, believing you've seen the universe at its most spectacular. You've admired the breathtaking photographs from the James Webb Space Telescope and thought humanity had finally reached the limits of what it could witness. Then, without much fanfare, another telescope quietly opens its eyes, and everything you thought you knew begins to change. But before we uncover what Euclid has revealed, take a second to subscribe to the channel. We're on the journey to 1,000 subscribers, and your support helps us continue bringing you the most fascinating discoveries from space, science, and history. Now, let's see why astronomers say these images are changing everything. At first, nobody expects anything extraordinary. After all, space telescopes have shown us beautiful galaxies before. Nebulae glowing in brilliant colors, distant stars shining across impossible distances, and cosmic landscapes that seem almost artistic. But as the first images begin arriving from a telescope called Euclid, astronomers slowly realize they are not looking at ordinary photographs. They are looking at something far stranger. The images are breathtaking, but not because they are beautiful. They are breathtaking because they expose a universe that feels unfamiliar. Scientists gather around their screens, zooming into the first observations. They aren't simply seeing galaxies scattered across space. Instead, they find enormous structures, hidden patterns shaped by invisible forces, and connections stretching farther than anyone expected. Quietly, many admit they weren't prepared for what they were seeing. And this is only the beginning. Unlike the James Webb Space Telescope, Euclid was never built to focus on a single spectacular galaxy or capture dramatic close-ups of colorful nebulae. That was never its purpose. Its mission is far more ambitious. Launched by the European Space Agency in July 2023, Euclid traveled nearly 1.5 million kilometers from Earth to Lagrange Point 2, a stable location in space where it could observe the universe without interference. From there, it began attempting something humanity had never tried before. Instead of examining one object at a time, Euclid set out to map the universe itself. Its enormous field of view allows it to observe vast regions of the sky in a single exposure, while maintaining extraordinary detail. Entire populations of galaxies appear in one image, each one sharp enough to study individually. For the first time, scientists can see not only countless galaxies, but also how millions of them connect across unimaginable distances. But Euclid isn't simply photographing light. Hidden within every observation is something even more remarkable. By measuring incredibly subtle distortions in the shapes of distant galaxies, distortions created by gravitational lensing, Euclid reveals the invisible influence of dark matter. It is not showing us dark matter directly. Instead, it is revealing the fingerprints left behind by something we still cannot see or fully understand. Slowly, a disturbing picture begins to emerge. The telescope is exposing what many scientists describe as the skeleton of the universe, an enormous framework shaped almost entirely by invisible matter. When Euclid transmitted its first great mosaic of the southern sky, researchers were stunned into silence. During only a brief observing period, the telescope captured 260 separate images, covering an area roughly 500 times larger than the full moon. Once stitched together, the mosaic revealed millions of stars and galaxies stretching across space with astonishing clarity. Yet the numbers carried an even greater surprise. Everything visible inside that enormous mosaic represented only about 1% of the complete survey Euclid will eventually produce. Suddenly, the image looked much smaller than it first appeared. What seemed unimaginably vast became nothing more than a tiny fragment of something incomprehensibly larger. Researchers could zoom from gigantic cosmic structures all the way down to individual galaxies without sacrificing detail. They watched matter organize itself across billions of light years, creating patterns too enormous for any previous telescope to reveal. It became obvious that this wasn't simply another astronomical photograph. It was the first page of what would become the largest and most detailed three-dimensional map of the universe humanity has ever attempted. And with that realization came an uncomfortable thought. If 1% already looked this overwhelming, what would the remaining 99% reveal? The answer began emerging from a familiar region of space known as the Perseus cluster, located roughly 240 million light-years from Earth. Astronomers had studied Perseus for decades. They believed they knew it well. The new Euclid image showed more than 1,000 known galaxies, along with over 100,000 faint background galaxies far beyond the cluster itself. Then someone looked closer. Hidden among those familiar galaxies were more than 630 dwarf galaxies nobody had ever seen before. They had always been there. They were simply too faint for previous surveys to detect. This discovery mattered far more than their numbers suggested. Dwarf galaxies are extraordinarily sensitive to the gravitational pull of dark matter. Their positions, shapes, and subtle distortions act almost like invisible markers, tracing where dark matter gathers throughout the cluster. If hundreds of these galaxies had remained hidden until now, then perhaps the invisible structure surrounding them was far more complicated than scientists had imagined. For years, dark matter had been treated as one mysterious ingredient within the universe. Euclid's images suggested something far more unsettling. Perhaps the universe isn't merely filled with dark matter. Perhaps it is built around it. The surprises didn't stop there. Euclid also began exposing details hidden inside nearby galaxies that had been studied for generations. Within NGC 6822, astronomers identified low metallicity stars whose chemical composition closely resembles conditions found in the early universe, offering a rare glimpse into how galaxies formed billions of years ago. Inside the ancient globular cluster, NGC 6397, Euclid resolved faint stars near the outskirts that had previously disappeared beneath the overwhelming brightness of neighboring stars, revealing new clues about the Milky Way's long history. Then came the Horsehead Nebula. Long famous for its dramatic appearance, it seemed like one of the best understood regions in the night sky. Yet Euclid's remarkable sensitivity uncovered evidence suggesting the presence of free-floating planets and Jupiter mass objects wandering through space without parent stars. If these lonely worlds were so common in one familiar region, how many more might exist throughout the galaxy? With every new observation, the universe appeared less peaceful. It became crowded, restless, constantly reshaped by forces both visible and invisible. As researchers continued combining more of Euclid's observations into increasingly larger maps, another discovery quietly emerged. The galaxies weren't randomly scattered across space at all. Instead, the deeper scientists looked into Euclid's growing map, the more one uncomfortable truth refused to disappear. The universe was not random. For generations, astronomers had known that galaxies were not sprinkled across space, like grains of sand. There were hints, scattered pieces of evidence, suggesting that something larger was shaping their positions. But hints are very different from seeing the entire picture. Then Euclid arrived. As image after image poured back to Earth, researchers began stitching them together. Slowly, an extraordinary pattern emerged. Galaxies were arranged along immense filaments, colossal cosmic highways stretching across hundreds of millions of light years. These enormous strands intersected at dense crossroads where giant galaxy clusters gathered, while vast empty regions lay between them, like oceans separating continents. The more scientists zoomed out, the stranger the universe became. It no longer resembled random space. It looked startlingly similar to a gigantic neural network, with matter flowing through invisible pathways that connected nearly everything. Only one problem remained. Almost none of those pathways could actually be seen. They were shaped almost entirely by dark matter. For decades, these cosmic filaments had existed mainly as theoretical predictions supported by computer simulations. Now, Euclid was allowing astronomers to witness their influence directly. Galaxies bent. They stretched. They aligned themselves in ways that made no sense unless something invisible was guiding them. The terrifying part wasn't discovering that these filaments existed. It was discovering how enormous they truly were. This vast cosmic web dominates the observable universe. Every galaxy, every cluster, every enormous void between them exists inside this hidden framework, following pathways created by forces humanity still cannot touch, measure directly, or fully explain. As researchers continued examining the images, another remarkable ability of the telescope began revealing itself. Euclid wasn't simply photographing galaxies. It was weighing the invisible. One of its greatest strengths lies in measuring gravitational lensing with extraordinary precision. Whenever light from a distant galaxy passes through a massive concentration of matter, gravity bends that light before it reaches Earth. Normally, those distortions are almost impossible to notice. But Euclid was built specifically to detect them. Across millions of galaxies, those tiny distortions gradually combined into something extraordinary. A hidden map. Massive concentrations of dark matter revealed themselves, not because they emitted, but because they quietly warped the space surrounding them. Entire regions of the universe appeared to bend reality itself. What made this discovery deeply unsettling was the simple fact that none of those enormous structures could actually be seen. They produce no light. They reflect no light. They remain completely invisible. Yet together, they outweigh every star, every planet, every nebula, and every galaxy visible across the cosmos. The implication was impossible to ignore. The dominant form of matter in the universe is something humanity cannot observe directly. Instead, we know it only through the silent influence it exerts over everything else. Every galaxy drifts according to its gravity. Every cluster forms because of its presence. Entire regions of the universe owe their existence to something we still cannot identify. Then Euclid looked even farther, much farther. Some of the galaxies appearing in its earliest observations were located more than 10 billion light-years away. That means the light reaching the telescope today began traveling long before Earth even existed in its current form. Each distant galaxy became a message from another age. Because light requires time to travel, Euclid wasn't simply looking across space, it was looking backwards through history. Within a single image, astronomers could observe nearby galaxies as they exist today, while simultaneously seeing distant galaxies exactly as they appeared billions of years ago. Past and present existed together in one extraordinary photograph. For the first time, researchers could watch cosmic history unfold across most of the age of the universe. As they compared galaxies from different eras, another surprise emerged. Large-scale cosmic structure appeared to have formed far earlier than many models predicted. Dark matter gathered into massive concentrations surprisingly quickly. Galaxies followed soon after. The universe seemed to organize itself with astonishing efficiency. If these observations continue to hold, scientists may have to rethink not only how galaxies formed, but whether our current understanding of gravity tells the entire story. And then came perhaps the most unsettling number of all. Everything Euclid had revealed so far represented only about 1% of its planned survey. 99% remained unexplored. For the next 5.5 years, the telescope would continue scanning the heavens, filling enormous gaps, refining measurements, and exposing structures nobody had even thought to search for. If 1% had already transformed astronomy, what would happen when the remaining 99% arrived? Researchers increasingly realized that Euclid wasn't simply taking photographs. It was building one of the largest scientific datasets ever created. A map so detailed that it could fundamentally reshape cosmology itself. Dark matter, dark energy, the expansion of the universe, even the laws governing gravity. Nothing seemed completely safe from revision. Then the telescope uncovered something equally unsettling. Not where galaxies existed, but where they didn't. Across the universe lay gigantic cosmic voids, enormous regions stretching hundreds of millions of light years where remarkably few galaxies could be found. At first glance, they appeared empty, but Euclid revealed that emptiness itself possessed structure. These voids were carefully outlined by the same invisible framework responsible for building galaxy clusters. Their boundaries appeared almost sculpted. Even regions containing almost nothing seemed to obey invisible rules. Astronomers began noticing another possibility. The distribution of galaxies surrounding these immense voids suggested that dark energy might be actively pushing matter away, accelerating the expansion of space itself. These weren't merely empty gaps. They resembled enormous pressure zones where the fabric of the universe was being stretched apart. The implication felt deeply unsettling. Perhaps the large-scale universe isn't simply expanding. Perhaps it is continually being rearranged. That possibility lay at the heart of Euclid's mission. The telescope wasn't built only to study dark matter. It was also designed to investigate dark energy, the mysterious phenomenon believed to drive the accelerating expansion of the universe. By measuring the precise positions and redshifts of billions of galaxies, Euclid can reconstruct how quickly the universe expanded throughout cosmic history. Even its earliest observations hinted at something unexpected. Tiny deviations, small enough to avoid headlines, large enough to attract attention. Again and again, measurements appeared to drift slightly away from predictions. No single observation proved anything. But together, they formed a pattern scientists could not ignore. Perhaps dark energy is not constant after all. Perhaps it evolves. If future observations confirm that possibility, our understanding of cosmic history would need fundamental revision. The force determining the ultimate fate of the universe may be far more dynamic, far more complicated, and far less predictable than anyone imagined. Yet while Euclid continued transforming our understanding of the cosmos, another challenge quietly emerged. For the first time in history, scientists were confronting a universe too large for the human mind to fully comprehend. The problem was no longer collecting information. The problem was understanding it. Euclid wasn't mapping thousands of galaxies. It wasn't even mapping millions. It was charting billions. Every observation added another layer to an unimaginably vast three-dimensional map of space and time. No individual researcher could hope to recognize every meaningful pattern hidden inside such an enormous archive. Human intuition simply breaks down at this scale. The relationships become too vast. The structures become too complex. The hidden connections become impossible to visualize. So astronomers have begun relying increasingly on advanced algorithms and artificial intelligence to analyze what Euclid observes. In an extraordinary twist, machines are helping humanity understand discoveries made by another machine. That creates a strange feedback loop. The more powerful our telescopes become, the more dependent we become on intelligent systems capable of interpreting realities beyond normal human comprehension. Perhaps that is the most unsettling lesson Euclid has taught us so far. Not that the universe is mysterious, but that reality itself may be organized on scales our minds were never evolved to understand. And perhaps the telescope's greatest revelation isn't hidden somewhere among distant galaxies. Perhaps it is much closer than that. Perhaps Euclid is quietly revealing the limits of human understanding itself. Dark matter, dark energy, gravitational lensing, accelerating expansion. Together, these invisible phenomena shape almost everything in the cosmos. Yet despite all our technological progress, they remain among the greatest unanswered questions in modern physics. Euclid isn't simply revealing the universe, it is revealing how much of the universe we still do not understand. The deeper scientists explored Euclid's observations, the more they realized they were standing at the edge of something far bigger than a new telescope mission. They were standing at the edge of the unknown. For decades, astronomy has relied on a handful of extraordinary ideas to explain how the universe works. Dark matter, dark energy, gravitational lensing, accelerated expansion. Together, these invisible phenomena appear to govern almost everything on the largest scales imaginable. Galaxies move because of them. Clusters form because of them. Space itself expands under their influence. And yet, despite decades of research, they remain among the greatest mysteries in modern science. The theories describe what these forces do remarkably well, but they still cannot fully explain what these forces actually are. That is where Euclid changes everything. Its observations are so precise that they expose just how much of our understanding rests on unanswered questions. Scientists can now map the fingerprints of dark matter with astonishing accuracy. They can measure the expansion of the universe more precisely than ever before. They can calculate how gravity bends light across billions of light years. But after all those measurements, one uncomfortable truth remains. The universe is behaving exactly as expected. According to theories built upon phenomena we still cannot explain. In a strange way, Euclid isn't only revealing the universe, it is revealing the limits of human understanding. It is showing us a cosmos where the things that matter most are invisible, unexplained, and known only through the subtle influence they exert on everything else. At first glance, however, none of that uncertainty is obvious. The images themselves are breathtaking. Galaxies glow like islands of light floating through endless darkness. Nebulae twist into delicate clouds of color. Ancient star clusters sparkle with an almost artistic perfection. To anyone seeing them for the first time, they feel peaceful, almost comforting. But astronomers have discovered something curious. The longer they stare at these images, the less comforting they become. Because beauty in this case is not an accident, it is evidence. Every razor-sharp galaxy, every perfectly traced filament, every tiny gravitational distortion, each one is a visible signature of invisible forces acting relentlessly across unimaginable distances. These photographs are beautiful because the universe obeys its laws with absolute consistency. Gravity never pauses. Dark matter never releases its hold. The expansion of space never stops. What appears calm is actually motion. What appears still is constantly changing.